PyTorch comes with a couple of useful datasets already defined. Let's see what they are. So first is the tensor dataset that they've conveniently defined for us. Tensor dataset is very similar to the map style dataset that we first implemented, where we wrapped NumPy arrays. Here we can wrap tensors, and then the row at whatever index we've called is returned to us. And we saw this concat dataset in map style datasets, or in datasets add implementation. All this does is it takes one dataset and then concatenates it with another dataset. This usually works with finite datasets. And the chain dataset is a similar concept, but for iterable datasets. So you kind of, once you exhaust the iterator of one dataset, then you start with the iterator of the chain dataset, and so on. Another useful little dataset is the subset dataset, where we can pass it a full dataset and the indices that we want the subset to start and end with. Obviously, this is only going to work for map style datasets. This concludes our module on datasets. So we saw what datasets are. We even implemented a couple of our own toy datasets. But keep in mind that production datasets are usually super complex. So for example, if our dataset's underlying data store is a MySQL cluster, then it might be doing a complicated multi-join query against it. Or if its underlying data source is a Kafka stream, it might be subscribing to specific topics, keeping track of the stream iterator, or the stream cursor rather, getting messages from there and whatnot. A Hive data store might necessitate the implementation of a highly optimized access to that data store. But regardless of whatever complexity lies within the dataset, its public interfaces remain super simple, which is get item, len, and iter. And that is what the clients of the dataset will usually care about.